Hi, in the previous lesson we talked about heat transfer, and I took my time to tell you the differences between thermal energy and heat. Now we talk about conduction also, and I told you what a conductor is. That conductors, they have the tendency or they have the capability of transferring electrons from one part of a body to another part of a body, or from one stage, or let's say from a material to another material. That's the reason we call them the conductors. Why the insulators don't have the capability to do that. And today we need to know that temperature is the measure. We need to know that temperature, we need to know what temperature is. Temperature is a measure of the average kinetic energy. The measure of the average kinetic energy of an object's particle. Now, when many times you've been hearing about the temperature, or you say I'm sick and I feel my temperature is increasing, and you've not taken your time to know what the temperature really means. What temperature means is this: temperature is the measure of the average kinetic energy of an object's particle. That is to say, we have particles in every substance or every object. For example, let me give the shape or the particle of a solid. I told you before now, the particle of a solid is in this form. It's joined together because they're not free to move. We say the particle are fixed together because they're solid, and that's the reason we say they have a very low kinetic energy. They're not free to move the way all liquid and solids are free to move. Now, when you want to know the temperature of this thing, you have to measure the average kinetic energy, because the particles are vibrating against each other. They have kinetic energy, and because of their position, before now they were together in a position, and we say they possess potential energy because they were standing in a position, they were not moving at all. But when you apply heat, there's going to be a tendency that the potential energy will convert to kinetic energy. And now when the potential energy converts to the kinetic energy, as the particles are vibrating and moving against each other, we will say the temperature of that body. If you put a thermometer is used to measure the temperature of the body. If you put a thermometer inside it, you find out that the thermometer is increasing, means the temperature of the body is increasing. Now we say the temperature of this body is the measure of the average kinetic energy of the particle in it. The measure of the average kinetic energy of the particle inside this body is called the temperature of that body. And also we have to understand that when heat moves into substance, the average kinetic energy will have to rise. Before now, we need to know that the particles of this of a solid material or a solid object will have potential energy because of the position, and also they possess kinetic energy because they're vibrating slowly around a fixed position. So now when you want to improve the temperature, you have to turn or convert the potential energy into kinetic energy. As the temperature increases, and as heat energy is moving into the particles temperature will increase. And as the particles temperature is increasing, that means the kinetic energy, the rate of vibration of the particles against each other, is also increasing. And after that, we'll talk about a conduction. And now let's move to the other types of heat transfer we want to talk about today. Now we'll stop here in the last lesson, and this lesson we're going to talk about the next one, which is an example of how we can transfer heat energy by the process of conduction. And we want to consider what we mean by a conductor and an insulator. Why does metal feel colder than wood if they are both in the same temperature. For example, you cook a metal and a wood, you put both in a pot and you start to cook them, you're boiling them. If you apply heat energy, you find out that the metal will be hotter than the wood. Why is this? Metal is a conductor, wood is an insulator. That is to say, the particles, the electrons in metals are free to move easily, while the electrons in the insulators are fixed together. They're not permitted to move at all, and that's the reason the metal will get hotter than the wood, even if they are boiled or they're being heated with the same temperature. Metal conducts heat away from your hand. The metal will conduct heat away from your hands. Wood do not conduct the heat away from your hands as well as the metal, so the wood feels warmer than the metal. Now look at this example is given here. When you hold a metal and you're holding a wood, the metal conducts the heat away from your hand. That is to say, if your hand is warm, the metal will conduct the heat away from your hands. Wood do not conduct the heat away from your hands as well as the metal, so the wood feels warmer than the metal. The wood will feel warmer, the metal will not feel warmer. And that's the reason we say the metal feels colder than wood, because they lose the electrons. When electrons are transferred into the metal, immediately the electrons will have to move away to another body touching them. That tells you that electrons are free to transfer within the metal materials, and they're not free to transfer in the wooden materials. Now the next one we'll talk about is convection. Convection means what happens to the particles in a liquid or gas when you heat them. Whenever you talk about convection, you're talking about the heat transfer in which the heat has been transferred through the particles of liquid or gas. The particles spread out and become less dense. Now when you try to heat particles in convection, you find out that particles will have to spread apart, and they start to move and become less denser than the way they used to be before. And this example is what we find in fluid movement. Cooler, more dense fluids sink through warmer, less dense fluids. If you could remember, we were talking about warm air and cold air. I told you guys that the warm air rises to the atmosphere, while the cold or the cooler air goes down. In effect, warmer liquids and gas rise up. Cooler liquids and gas will have to sink. So now when this is occurring, when you're trying to boil water, you find out cooler water sinks down. When you're applying heat energy to water in a container, the cooler water sinks down, and when it cools at the surface, it goes down to the bottom of the pot. Convection currents makes the hot water to rise. The hot water rises to the upper part of the pot, while the cooler water sinks down to the bottom of the container. So this continues to occur time after time, and this is the reason why heat energy could be transferred in the water you're boiling using a pot. And I used this as an example before when we were talking about the transfer of heat energy, maybe talking about convection currents around the sea, or talking about sea currents and warm currents. Now this is why is it windy in the seaside? The land is warmer than the sea. I told you before now, the land has a tendency of absorbing more heat energy faster than the water. This land warms the air above it rises. Now the cold air from above the sea moves in to take the place of the warmer air that is rising. Now when the warm air rises to the atmosphere, the cooler air will have to go back to the space of the warmer air to replace its space, and this is called convectional currents. And also, whenever you want to talk about the reason why you use this in the refrigerator, also where the freezer compartment put in the fridge, it is put at the top side. Cool air sinks, so it cools the food on the way down. Freezer compartment, it is warmer at the bottom, so the warmer air rises, a convection current is set up. Thank you for stopping today. We'll continue the next lesson.